Hello, Algebra 2 folks, and welcome to Describing Graphs. So today you're going to need your notes, a pencil, and the foldable that I gave you in class. So we're going to start out by talking about the learning targets. The learning targets are, I can determine where the local maximum and minimums are on the graph. I can determine where a graph is increasing or decreasing, and state the intervals. And the last learning target is that I can find an x-intercept and a y-intercept of a graph. Now, we're also going to be working with domain and range today, but that learning target is what we did yesterday. So if you take out your foldable and cut it all out, you cut out the outsides. You don't cut anywhere else except for between the x-intercepts, just on the red area, and between the relative maximum and minimums and the zero roots and solutions. And then you fold on the green area. Okay, so you can see that you're going to cut on that and fold on the other. Okay, and then when we open it up, if we open the doors up, once we fold them over, you will see that I have the graph in there. All right, so let's just go through these. And the first door that we are going to talk about is the X and Y intercept door. So that's up here in this area, okay? So we're going to talk about what is the point where the graph crosses the x-axis. Those are called the x-intercepts. So go ahead and write x-intercepts. And if you notice, I have that in purple. And then I'm going to go ahead on the graph. And in purple, I'm going to show you what the x-intercepts are. So one of them is -3, 0. One is 1, 0. And another x-intercept would be 5, 0. The y-intercept, which I'm going to do in red, is the point where the graph crosses the y-axis. So I'm going to put a point where it crosses the y-axis in red, and that point would be 0, 2. Okay, now I'm going to open the door for the increasing and decreasing. And a function is increasing. I'm doing that in yellow, over the interval where the y value increases as the x value increases. So if you look at this graph, where the graph is increasing from left to right, one area is there, okay? So that's an increasing part of the graph. And another part of the graph that's increasing is where you see the other yellow. The function is decreasing on the interval if the y value is decreasing as the x value is increasing. So the decreasing, you can see, is going to be what's left over. That's what's going to be in the blue. So that's going to be the decreasing part of the graph. Okay, now we're going to go to relative max and mins. If you open it up, you'll see the maximum is in green here, is the y value of the highest point of a particular region. So if I'm looking for the highest point of a part of the graph, now I'm not looking for the arrows. Relative means it could be the highest point, but it's not necessarily the highest point, because the highest point is probably over here somewhere, because this is going to continue on to infinity. So a relative max is this point right there in green, that it's kind of a high point for that area, but it might not be the highest point for the whole graph. All right, and that's -1, 4. So that takes me to the minimum value. The minimum is the y value where it might be the lowest point, but not necessarily the complete lowest point. So the lowest point, if you notice, this graph is going to continue on to the lowest point forever here. But if you notice, this point right here is called a relative minimum because it's going to be the lowest point within the certain area of the graph. And that point is 3, -4. Okay? Then I'm going to open the zeros, roots, solutions, and x-intercepts because you should know that zeros, roots, solutions, and x-intercepts are all names that describe the x value that in which it crosses the x-intercept. Okay, so that's where the y value is 0. So these purple dots that we talked about for x-intercepts are also called zeros, roots, and solutions. Okay, so there's 4 names that mean the same thing here. All right, so now we're going to do a couple of examples in your notebook. Okay, so if I have this graph, I should be able to determine the x-intercepts, the y-intercepts, the increasing intervals, the decreasing intervals, the maximums, the minimums, the domain, and the range. All right, so let's talk about x-intercepts. X-intercepts are the same as roots or solutions. Okay. Those are my x-intercepts. So my x-intercepts are -3, 0. And remember, x-intercepts have a y of 0, -1, 0, 1, 0, and 3, 0. All right. Now I'm going to go ahead and do the y-intercept. The y-intercept is where it makes the x 0. So that would be 0, 9. Excuse me. I'm sorry, I'm not feeling good. All right. Now I'm going to talk about the increasing intervals. The increasing intervals are where the graph increases. So this is where the graph increases. We're only looking at x values. Okay, so what is the x value? If I come up here to the x value, it's increasing from 2 to the x value 0. It's also increasing, you notice, right here. And that's from, oh, that should be -2. Okay, because that's a -2, sorry. Then it's also increasing from 2, and this goes on forever and ever and ever. So from 2 to infinity. Okay, your decreasing intervals, we also use x-intercept, there's x values only. So where is it decreasing? Well, it's actually decreasing here. So over here is -infinity, all the way to -2. Oops. And then it's also decreasing from 0 from here all the way until this point, which was 2. Okay, maximum, remember that's the relative maximum, might not be the absolute maximum because the maximum looks like this could go on to infinity for a long time, but this is my relative maximum right here. Okay, and that is 0, 9. All right, and then a minimum. Remember, the minimum is the relative minimum. It might not be the absolute minimum, but it's the relative. This is the absolute minimum because, see, it doesn't go down any further. So these would be called absolute minimums. And those values are -2, -15, and 2, -15. And then domain and range would be, go ahead and erase all this. We could use that little thing that we got in class a couple days ago, a little foldable. Okay, so let's look at this and see what the domain and range is. If I fold my domain over to here, I'm going to run into an arrow. So this would be negative infinity. And if I fold the right-hand side in, I'm going to run into an arrow. So that's positive infinity. Okay. Then if I do my range, that's my y values. If I fold, I'm going to fold up to negative 15. And then if I fold the top one down, I'm actually going to extend these out because this is not the tippy top. These can continue to go forever and ever. So I'm going to run into an arrow, which means I'm going to go to positive infinity. Okay, so these are some major key features for graphs that we want to know and be able to identify. All right, let's do one more. Here I have this graph. Let's take a look at the x-intercepts. The x-intercepts are where y is 0. So these are my two x-intercepts, negative 1, 0, and 3, 0. My y-intercept is where it crosses the y-axis. Okay, that's where it crosses the y-axis. That's 0, negative 3. My increasing intervals are where the graph is increasing. Okay, let me get a different color here because I've already used red. So let's do this blue. This is increasing here. So we go up to the x value, because remember it's x values. That would be 1. And then it's going to go on forever because we run into an arrow for infinity. Decreasing intervals, okay, would be the downward area. So this would be the decreasing, that would be the decreasing interval here. So that goes from negative infinity all the way to positive 1. Okay, maximums. There are no maximums because the maximum goes to infinity. So I'm going to put no relative maximums. If I talk about minimums, there is a minimum. This is not only a relative minimum, it's also an absolute minimum because absolutely, positively, this is the lowest point. So that point is 1, negative 4. Okay, that's the minimum. And then the domain, if I were to fold over for the domain, I'd run into an arrow. If I'd fold over the right side, I'd run into an arrow. So this is negative infinity to infinity. And the range, if I fold up to this point, it would be negative 4. And it goes all the way to positive infinity. So these are some of the key features that we have to be able to identify. X and Y intercepts, increasing and decreasing intervals, relative maximum and mins, zeros, roots, and solutions, and x-intercepts. Those all mean the same thing. And don't forget about domain and range, which is a key feature that we spent on for one day in class 2 days ago. Okay, that's all I have for you. I hope you have a great evening, and we'll see you tomorrow.